cool. Hey friends, it's Devin here with Make Anything, and I finally got a new Fusion 360 tutorial for y'all today. Based on responses to my last Cool Prints video, the most requested tutorial was for making these ambiguous shapes. You know them by now. They're these mind-boggling shapes that trick your brain into seeing two totally different objects depending on your point of view. I still can't get over how crazy these look on camera, and as weird as these shapes are, there is a method behind their madness. So as long as you have some basic skills down in Fusion 360, I hope I'll be able to teach y'all how to make your very own by the end of this video. And I would say this is a mid-level tutorial, so I'll be using shortcuts here and there, but I will walk through the entire process and make it as clear as I can. So keep watching if that sounds like a good time. Or if you just need something to fall asleep to, you're all welcome here. Anyways, let's get started. But before we jump into Fusion 360, let's bring some pen to paper and lay down the ground rules, because some shapes are easier to combine than others. Let's pretend this line is our mirror, and on either side we can draw the two shapes that we want to combine. So to recreate Kokichi Sugihara's original ambiguous cylinder, we would have a circle on one side and an angled square on the other side. The first rule is that these two shapes must be of equal width with respect to our mirror, what Professor Sugihara refers to as vertical correspondence. We're dealing with an object and its own reflection here, so we can't just make a wide object turn into a narrower one. At least not without some extra tricks. For example, we could still combine a square with a tilted square, which has shorter sides, but oriented this way they still share that vertical correspondence. We can also turn one circle into two smaller circles. That way they still share the same width. So vertical correspondence of the outer boundaries of the shapes is essential. It also helps to have vertical correspondence for sharp points, like the tip of my star to heart. Edges that don't line up can produce strange shadows, which will require more careful lighting to pull off a convincing illusion. In general, the more similar the shapes are, the better this will work. As the two shapes diverge, the top surface of the cylinder will get crazier and usually harder to 3D print. So when starting out, try to keep your shapes somewhat similar, especially considering their vertical correspondence. Here's a page of shapes I brainstormed for the illusion. As you can see, I tried to keep the shapes as simple as possible. And for this tutorial, we're gonna stick to single outline, closed shapes. So as you saw with the two circles, there's always ways to work around that. But for today's demo, I'm specifically gonna show you how to make a circle to triangle ambiguous shape. It's about as simple as it gets, and should hopefully get you on your way to making different shapes of your own. So, let's get into Fusion 360. We'll start out by creating a new sketch on the top plane. And in that sketch, we'll use the line tool to draw a horizontal line and a vertical line, both passing through our origin. Let's select this line, hold Control, and select the origin as well. Then right-click and select midpoint to constrain it. That constraint tool stays open, so we can just click the other line and the origin to constrain those as well. And this just keeps our lines symmetrical and pretty. Select this vertical line and hit X to make it a construction line. It's just there to mark the center of our shapes. This horizontal line represents our mirror. Basically, we're recreating our paper sketch. So up top here, we can draw our circle out from the center line and a second circle to give our shape thickness. Hit D to use the dimension tool, and we'll make this outer circle 30 millimeters in diameter. Whoops, looks like our scale is a bit off. Let's just shrink this inner circle down and bring everything closer together. We can set the thickness of our cylinder by selecting both circles with the dimension tool and let's make that 2.4 millimeters. Now remember, we need to maintain our vertical correspondence. So I can draw a vertical line that's tangent to the circle to help us with that. Now we could just draw a triangle that lines up with that circle, but if we offset that 2.4 millimeters inwards, we'll find that the point of the inner profile does not share vertical correspondence with the inner circle. So instead, let's delete our outer triangle and sketch our inner profile first. We'll constrain this one so the bottom is horizontal and make all three sides equal. Let's also snap this top point to the center line. Now we can draw a line up from the boundary of the triangle up to the boundary of the circle and constrain it to be vertical and tangent. From there, we'll use the offset tool and go out 2.4 millimeters. Once again, the outer boundary is too wide, but my simple fix is to add a center point circle to each corner and make it tangent to the outer triangle. That essentially gives our shape 2.4 millimeter fillets, so it will match the width of our circle. We can turn these into construction lines, and let's make these shapes equidistant from our virtual mirror. I'll add points where our shapes are closest to that mirror in the center, and just give them an arbitrary distance of 10 millimeters. I'm not entirely sure why this triangle is still blue, aka not fully constrained, but for a simple design like this, it won't mess anything up. So let's exit this sketch, save our project, and move along. Next, let's create a new sketch, this time on the right plane. Hit P to open up the project tool and select the last 2 points we made so we can reference them in this new sketch. Now we'll add some crisscrossing diagonal lines coming down from both those points, and another line from the origin down to their intersection point. Give that line a vertical constraint so these lines stay symmetrical. These crossing lines actually represent the viewing angle for our illusion. So you're welcome to play around with it, but I've found that 110 degrees here works well. That's it for this sketch, so we can hit Finish Sketch, and now it's time for us to switch to the Surface toolset. Most of my work is generally done using solid modeling, but surfaces can be really useful for building weird and complex forms, like these ambiguous shapes. We'll start by selecting the Sweep tool, and then highlighting all the parts of our triangle, making sure to exclude those pointy corners. Then we'll click over here to select our path, and click this diagonal line to build a surface for the inner and outer profiles of our triangle. Now open up the sketch tree on the left here so we can turn both those sketches back on, because we want to do the same thing in the opposite direction with our circle profiles. And it looks like I didn't sweep quite far enough because we want these shapes to completely pass through each other. So I'll just click and drag these points a bit further down. It's pretty cool that Fusion lets us do that from outside the sketch. Anyways, we've got our intersecting projections now, and what we're actually interested in is the curve that is formed at their intersection. That's what will produce our desired shape. But at this point, it's not a usable curve yet. So let's start by focusing on the outer surfaces. We can hide the inner surfaces by selecting them and hitting V to change their visibility. Now, to make this curve usable, we can use the Trim tool. First, select one shape to be the tool, then select the top and bottom of the opposite shape so they turn red. Sometimes it doesn't select right, but let's just try again. There we go. Hit OK. And if we change the visibility of our project to show edges, we'll see the surface with those curves we want. We can select this part and find it in the bodies tree, right-click and select Remove, just to keep things organized. Now, within this shape, we can see a few different curves, but if we view it from the side, we can find the edges that go from the far left to the far right and kind of through the center, as opposed to this more vertical one. So to isolate that curve, we're going to use the Patch tool and just highlight the edges that make up that loop. That forms a new surface, and once again, we can remove the previous surface. We're left with this potato chip shape, and if we view it from our two specific angles, we can already see that it's transforming from a circle to a triangle. You could even just use the thicken tool and make it into a solid model, just like that. Pretty cool, but not exactly what we're after. So let's undo that thicken, hide this surface for now, and repeat the process up to here with our inner profiles. Again, we'll select trim, remove these extra bits, and make another potato chip surface with the patch tool. And just a note, sometimes you have to deselect this enable chaining setting to make sure you're only selecting the desired curves, although this shape is simple, so it's not necessary. We should be left with these two surfaces. And don't worry if they intersect or look really crazy, because these are still only for reference. We'll make our first actual surfaces now using the ruled surface tool. Select the inner edge first, set the type to direction from this drop-down menu, and then select the vertical z-axis here to produce a vertical surface like this. We'll make that distance minus 25.4 millimeters, so it's exactly 1 inch, and hit enter to confirm. Let's repeat that with the outer edge to make the outer wall of our shape, and then we can remove these top surfaces. Finally, it's starting to look like our desired ambiguous shape. Next, we'll create the top surface that connects the inner and outer walls. To do that, we need some more reference lines. So we'll create a new sketch, and we can just select any plane because we're going to turn on this 3D sketch option that will allow us to draw lines anywhere in 3D space, instead of just on one plane. Now we can select the line tool and actually see the mouse snap to the existing points on our surfaces where those vertical edges meet the top curves. We basically want to use all those snap points to draw lines between the walls, like so. And generally, the more reference lines we have to work with, the better. So I'll draw between all these points, just connecting points from the outside wall to the nearest points on the inner wall. The more complex your shape, the more lines you may need. This part kind of just requires you to feel things out until something works. After we finish that sketch, we'll use the patch tool again and start patching up the top piece by piece. First, disable this chaining option so we can select smaller sections, and we'll create a loop using the wall edges as well as our 3D sketch lines to create those sections. We could try to make a larger section, but in this case it doesn't work, so we'll stick to the smaller patches. Again, you just need to try things until it works. Next, we'll do this big arc, and sometimes it works better to turn off the 3D sketch and only use the edges of the existing surfaces, but in other cases, Fusion won't let us select the full loop that way. In this case, it only works if we use the curves from our sketch. I'm not entirely sure why, but this transition does look nice and smooth, so I'll roll with it. As for the rounded points like this one, it's generally better to turn off the sketch and select the actual edges, because that will let us smooth this out more. You can see how the patch dips here, and these edges have a hard crease. We can fix that by referencing these edges, labeled 1 and 3, which correspond to the first and third edges on this list. So for those two, we'll change this setting from connected to tangent, and that immediately smooths out the connections here. This surface is bulging a bit more than it needs to, so we can go back in here and lower the weight value until it looks good. In this case, 0.3 works well. Hit OK, and we've got our continuous top surface. Now we can use the stitch tool and highlight those top surfaces to combine them into one single patch. Then we can select the whole surface and use the move tool. Set the move type to translate and check this create copy box, and then drag the surface down in the Z direction and make that value minus 25.4 to match the height of our shape. Hit enter and we've got our bottom surface. Now we should be able to use the stitch tool and combine all of our surfaces. Those green edges indicate success, and accept that to make our completed cylinder. Over here, we should now see one single solid model as indicated by this little icon. And if we do a section analysis, sure enough, it's solid. So we've got our shape. Next, how about we add some custom supports to make this easier to 3D print? For a shape like this, it's super simple. We'll just use the Move tool again, select the shape, select Create Copy, and drag that downward. We'll type in -25.4 to match the height, then add -0.18 to move it down a tiny extra bit. Hit Enter and we're left with this thin gap that will act as a breakaway support. Next, let's create a sketch on the left plane and draw a rectangle. We can turn off 3D Sketch, and then we can just bring that rectangle up near the bottom of our top cylinder. I'll add this small line and give it a dimension of 0.3 millimeters just to help us eyeball and make sure that there's at least that much support material under the lowest point here. Then we'll use the Extrude tool and cut away the rest of that bottom body, which leaves us with this nice flat bottom that will print more easily. Whenever we model multiple bodies in a project, I like to give them separate appearances to make sure that they stay separate. Anyways, there's our shape with supports. Finally, let's design a mount so that we can stick this on top of a stand. We'll start by selecting the top plane and constructing an offset plane. We'll bring it down near the bottom of our cylinder where the mount won't be visible when viewing the illusion. -40 millimeters looks good here. Then we'll select that plane and start a new sketch. I'll start with 2 concentric circles in the center, make the inner one 3.376 millimeters to fit a 1/8 inch rod with a tiny bit of clearance. And we'll make the distance between the circles 1.6 millimeters, so it's a multiple of the standard 0.4 millimeter nozzle I'll be printing with. Next, we'll draw some straight lines out from the center of our circles to create some struts. Depending on the shape, I'll use 3 or 4 struts like this, and with each line, I'll create several offsets. 2 millimeters, 2.1 millimeter, -2 millimeters, and -2.1 millimeter to make 4 millimeter wide struts. We'll also use the Project tool to reference this inner edge and offset that 0.4 millimeters, and again 0.5 millimeters. I'll finish off my struts, and to save some time I can just mirror these offset lines across the vertical center line. That's all we need here, so we'll hit E to switch to the Extrude tool, and we'll start by cutting away these little channels for our mount by selecting all these profiles that overlap with our cylinder. Then we'll extrude that up 1.2 millimeters. Hit Enter and check out the result. To make these little cuts print as clean as possible, I like to chamfer this top edge to get rid of the overhang. These cuts are 0.5 millimeters deep, but in classic Fusion 360 fashion, the chamfer will only work if we make it 0.499 millimeters. Now for the mount itself, we'll turn our last sketch back on and do another extrude, selecting everything except for these thin sections that make up our clearance. Let's extrude that up 1.2 millimeters and make sure it's a new body. I'll color that as well, just for fun. Now we can hide the cylinder and finish up this mount. We'll extrude again, selecting this ring, and take that down 2.4 millimeters. Then extrude this inner circle up 0.7 millimeters to stabilize the stand a bit more. I like to add 1.1 millimeter fillets to these corners for a tiny bit of extra strength, and I'll also add a 0.6 millimeter chamfer to these top edges so the parts snap in more easily. Also, some 0.6 millimeter fillets on these corners for a cleaner print. Okay, we're almost set. Let's just adjust our mounting position a tiny bit to make it as low as possible. If we select these two edges, we can see the minimum distance between them here in the bottom right corner. It's just over 1.7 millimeters. Not bad, but we can shave off that 0.7. So let's find our offset plane in the timeline, right-click and edit feature, and move it down an extra 0.7 millimeters. Everything should update with that change, and now we've got a nice mount that is totally hidden when viewing the illusion from the magic angle. Perfect. Let's turn on the support body and turn off the mount so we can save our cylinder together with the support as a single STL file. To do that, we'll just right-click on this top line of the feature tree and find the Save as Mesh option. Make sure it's set to save as one file, and we can also preview the mesh to make sure it's what we're going for. Then hit OK and save. As for the mount, we can save that separately by right-clicking on the body and selecting Save as Mesh right there. Same deal. That's it for Fusion 360. While you can arrange the bodies in there to be set up for printing, I personally like using this program for Mac called Pleasant 3D. It's just super simple to rotate and center the STL files so they'll show up ready to print in your slicer. I usually print these files between 0.12 and 0.16 millimeter layer height. Just make sure that supports are turned off because we've imported our own. And it's also a good idea to use the seam alignment settings to position the seam along the side of our cylinder so it won't be visible when viewing the illusion. Also, if you're using co-extrusion filament like MatterHacker's Quantum PLA, just make sure to orient the part so that the opposite views show up in the different colors. That orientation can vary based on the printer, but once you've figured it out, it generally stays the same. After printing, I like to use some clippers to pry off our support structure. Depending on your filament and print settings, sometimes it's super easy, other times it sticks a bit. Of course, you can adjust the gap size in Fusion 360 if it comes down to that, but hopefully it separates nice and cleanly. Next, we'll pop in our mount, which can get tricky, but this one worked really well. Then comes the rod, followed by the base. I'll press down from the center to make sure it's snapped in nice and snug, and then we should still be able to shift it around until it lines up perfectly in front of our mirror. From there, it's just a matter of getting the camera angle just right. It helps to use a telephoto lens to minimize distortion, and even lighting will also help hide the true weirdness of these shapes. Just mess around with it until it looks good. All right, that's a wrap for this tutorial. Let me know in the comments if you actually give this a shot. What kinds of shapes did you try to combine? Did they work? I appreciate any and all feedback, and as I mentioned, some shapes are definitely trickier to make than others, and I purposely chose to do a more simple shape for this tutorial so it would be accessible to more people. But I will be sharing the Fusion 360 project files with my Patreon supporters through the Make Anything Discord community, so if you want to see what extra steps went into some of those extra crazy shapes, it's as good a time as ever to join the fun. I'll make sure to put links in the description. Anyways, thanks so much for taking the time to watch this video. I'm always trying to keep things interesting, so give it a thumbs up and subscribe if you want to see more in the future. That's it for today though, so I'll see you in the next one. Until then, I'm Devin, this is Make Anything, and as always, stay inspired.